Welcome back to the deep dive. I'm really excited today to get into something that's, well, it's everywhere. And honestly, it often feels like magic. Artificial intelligence.
It really does. It's amazing how quickly it's become part of, well, everything.
Yeah, absolutely. I mean, from the virtual assistants we chat with, daily, to those incredibly spot-on recommendations on streaming
Oh,
platforms.
yeah, those are uncanny sometimes.
Right. And then you've got these powerful AI tools like ChatGPT and Daily that just seem to conjure creations out of thin air.
Mm-hmm.
So our mission today is really to pull back the curtain on all of that, to try and understand how AI actually works. We're going to dig into that fantastic stack of articles, research, and notes that you, our listener, provided for this deep dive.
And the goal isn't just defining AI, right? We want to get into the mechanics, connect the dots, maybe clear up some of the mystery around how this technology actually operates.
Exactly. Hopefully by the end, you'll have a much clearer picture of what's really going on behind the screen.
Let's do it.
Okay, so let's start basic. At its core, when we talk about AI, we're talking about computer systems doing tasks that normally need human intelligence.
Right. Things like creating art, like you mentioned, or
Yeah.
making decisions, translating languages, even handling customer service calls sometimes.
Yeah, all that stuff.
And maybe to be a bit more precise, AI is really about creating algorithms, models that can look at data, find patterns in it, and then make decisions or predictions based on those patterns.
Okay.
But what's really key, and I think often missed, is AI's ability to learn and adapt over time. That's how it gets better and tackles more complex stuff, sometimes even better than humans in, specific areas.
That learning aspect is crucial.
It is. And when we talk about how smart AI is, there's a really important distinction. Strong AI versus weak AI.
Ah, yes. This comes up a lot.
Yeah.
Because I think many people immediately jump to, well, science fiction, right?
They absolutely do. And that's generally where strong AI lives. It's this hypothetical idea of AI having human-like consciousness, self-awareness, real general intelligence.
Like the Terminator or Data from Star Trek.
Exactly like that. Machines that can think, reason, feel, make decisions just like us across pretty much anything. But, and this is the key part, it's still science fiction. We're nowhere near that.
Right. Good to clarify. So what do we have?
What we have, and what you interact with every single day, is weak AI, sometimes called narrow AI. These systems are designed for specific tasks that need human-like intelligence, but they're limited by their programming.
So they can't just decide to learn something completely new on their own?
Not really, no. They don't have consciousness or general reasoning. But what's kind of amazing about weak AI is how intelligent it can seem without any real understanding. It fools us,
How so?
Well, think about Siri, Alexa, Google Assistant. They use really sophisticated natural language processing and machine learning to understand what you say and respond.
Okay.
Or self-driving cars, chatbots, those recommendation engines. They're all incredibly powerful examples of weak AI doing very specific, complex jobs very well.
That makes sense. So even though weak AI seems super smart, it isn't actually thinking or self-aware. But what are some common misconceptions people still have, even those of us who try to follow this stuff?
That's a great question. One big one is definitely assigning human-like understanding or intention. Like when ChatGPT writes a poem, it's not feeling inspired.
Right.
It's just predicting the statistically most likely next word based on, well, tons and tons of text it's seen. It's pattern matching, essentially.
Okay, so it's not about feeling, it's about probability.
Exactly. Another misconception is underestimating how brittle it can be outside its training zone. A self-driving car might be perfect on mapped roads, but put it somewhere completely new, unexpected conditions, it can fail dramatically.
Ah, okay, so it's very good at what it knows, but struggles with the unknown.
Precisely. Understanding that gap perceived intelligence versus actual consciousness or broad understanding is really key.
That helps frame it.
And, to get even more specific than just strong and weak, we can actually categorize AI into 4 types based on capability. Think of it like stages or levels.
Okay, 4 types. Let's hear them.
All right. The most basic level is reactive machines. These just perceive and react. They don't store memories. They don't learn from the past. Very limited duties.
Sounds pretty simple.
It sounds simple, but think about IBM's Deep Blue, the chess computer that beat Kasparov back in the 90s.
Oh, right, yeah.
That was a reactive machine, no memory beyond the current game state. But it still beat a world champion. It shows you don't always need, a mind for incredible results. It kind of challenges our idea of intelligence itself.
That's a really good point. Wow. Okay, so that's reactive. What's next?
Next up is limited memory AI. These are more complex. They can store past data and predictions for a short time. This lets them look at recent information to make better immediate decisions.
Like remembering what happened a few seconds ago.
Exactly. Think self-driving cars again. They need to remember the speed and direction of other cars nearby to navigate safely. This usually involves models being continuously trained with new data or environments where they update automatically.
Okay, that makes sense. So reactive, then limited memory. What are the other two? Are they real yet?
Good question. The next two are still hypothetical. Future goals, really. First, there's theory of mind AI.
Theory of mind, like in psychology. Understanding others' thoughts.
Precisely. The idea is machines that could comprehend that humans, animals, even other machines, have thoughts, emotions, intentions that influence behavior, and then use that understanding in their own decisions.
Wow, that sounds complicated.
It is. We're just not there technologically or scientifically. Not even close, really.
Okay, and the final type.
The final, most advanced, also hypothetical stage is self-awareness. This is AI with human-level consciousness, understanding its own existence, its place in the world, recognizing others' emotional states, their needs.
So basically, the sci-fi AI we talked about earlier.
Pretty much. Like theory of mind, this is currently beyond our reach due to massive technological and scientific hurdles.
It's fascinating, though, to see that progression laid out, from simple reactions all the way to that aspirational goal of conscious AI. Gives you a real roadmap almost.
Exactly. It frames the journey.
Okay, so we've got the different types, but the big question is still, how does it actually work? How does AI do what it does? This is where we peek under the hood, right?
Yeah.
And I know Kevin Braith's research offers some great ways to explain this.
Yes, absolutely. Kevin has a knack for making this clear. So AI uses several key methods, and the big one, the real foundation, is machine learning.
Wait, that's
ML.
learning. Okay.
Right. It's
Yeah.
a core part of AI. It's what lets computers learn and get better on their own by analyzing data and adapting without needing someone to explicitly program every single step.
Learning from data, essentially.
Exactly. And there are three main ways it does this. First is supervised learning. Think of this like learning with a teacher or flashcard. You train the AI model on data that's already labeled, meaning you give it inputs and the correct outputs you want. The algorithm learns the relationship between them.
Like showing it pictures of cats and dogs and telling it which is which.
Perfect example, image classification, spam filters, speech recognition. They often use supervised learning. And fun fact, when you do those copy TCHAs online, identifying buses or crosswalks,
Yeah. Annoying, but yeah.
you're actually helping to create more labeled data for training these AI models.
No way. So while I'm proving I'm not a robot, I'm teaching one.
Pretty much. It's a fascinating loop.
Wow, okay. So that's supervised. What else?
Then there's unsupervised learning. Here, you give the algorithm data without labels, just the inputs. The AI has to find patterns, structure, relationships in the data all by itself.
So no answer key this time.
Nope. It's great for things like clustering similar customers together based on buying habits or finding weird anomalies that might indicate fraud. And a lot of generative AI creating text, images, music uses unsupervised techniques to mimic patterns found in massive data sets.
Okay, discovering patterns on its own. Got it. And the third?
The third main type is reinforcement learning. This is more like learning through trial and error. Think training a dog with treats or learning to ride a bike.
Right, you get better by doing and seeing what works.
Exactly. The AI interacts with an environment, takes actions, and gets rewards or penalties based on the outcome. It learns the best strategies over time. This is used a lot in robotics, playing complex games, or optimizing recommendation systems.
Supervised, unsupervised reinforcement. Those are the big three.
They are. There are others, like deep learning, which often uses neural networks, and transfer learning, but those three are the core concepts.
Okay. And you mentioned neural networks. That sounds important.
Very important, especially for deep learning. Neural networks are inspired very loosely by the human brain's structure. They use interconnected layers of artificial neurons to process data.
Not actual brain cells, though, right?
Yeah. Oh, no, definitely not.
Right.
They're mathematical functions, really. Each neuron takes inputs from others, weighs their importance based on what it's learned, does a calculation, and then passes a signal to the next layer.
So it's like a complex web of calculations.
Exactly. And the network learns by adjusting the weights, the strength of those connections between neurons over and over again, trying to get better at making the right predictions. They're super powerful for complex pattern recognition, like in images or speech.
It helps to picture it as connections getting stronger or weaker, based on success.
That's a good way to think about it. Another vital piece is natural language processing, NLP.
Right, understanding human language.
Yep. This is how AI processes, analyzes, and even generates human language, text, or speech. It's what lets you talk to Siri, or powers translation apps, or analyzes customer reviews for sentiment. NLP builds the bridge for us to interact with AI more naturally.
Crucial for things like chatbots.
Absolutely. And finally, you have robotics. This gives AI a physical body, essentially, a way to interact with the real world, move around, manipulate objects, gather physical data.
Like in manufacturing, or those Mars rovers.
Exactly. Manufacturing, healthcare, space exploration. When you combine AI's brain with robotics' body, you get machines that can perform complex, often dangerous tasks autonomously.
It really starts to paint a picture of how these pieces fit together. It reminds me of that Kevin Bray quote you mentioned. I really enjoyed the explanation of what is under the hood of AI.
Mm-hmm.
It really is like looking at an engine, not just the shiny outside, but seeing the interconnected parts making it all work.
That's a great analogy.
Okay, so to make this even more real, let's walk through an example. Say we want to build an AI model that can tell the difference between a bee and a wasp from an image. How would that actually work? There's like a 7-step process, right?
Yes, exactly. We can break it down into 7 key steps. It makes the whole process much clearer.
All right, let's do it. Step 1.
Step 1, data collection. First, you need data, lots of it. For our bee-wasp example, you'd gather thousands of images of bees and wasps. Along with the images, you might collect specific features, measurable characteristics like, say, the amount of hair, the shape of the abdomen, maybe wing patterns.
So features are the specific things you measure.
Exactly. Each image is an observation. And importantly, you need a target label for each image telling the model if it's a bee or a wasp. This whole collection is your training data set. And remember, the quality and quantity of this data is absolutely critical for accuracy later. Garbage in, garbage out, as they say.
Right. Data quality matters. Okay, step 2.
Step 2, data preparation. Raw data is usually messy, so here, you clean it up. You might correct errors, remove duplicate images, figure out what to do with missing information. Then, crucially, you address potential bias.
AI bias. What does that mean here?
It means your results might be skewed if your data isn't representative. For instance, if you had like 90% bee pictures and only 10% wasp pictures in your training set.
The AI would probably just guess bee all the time.
Exactly. It learns the imbalance. So you need to ensure a good mix, maybe randomize the order, check for unwanted correlations. Finally, you split your clean data. Most of it, maybe 80%, becomes the training set the model learns from, and the rest, say 20%, is kept aside as the testing set for later evaluation.
Okay, clean the data, remove bias, split it. Got it. Step 3.
Step 3, choose an algorithm. There isn't one best algorithm for everything. You pick one based on your problem. Remember supervised learning. Within that, common problem types are classification predicting a category, like bee or wasp.
Which is what we need here.
Right. Or regression predicting a continuous number, like temperature. Or clustering grouping similar things without labels, which is unsupervised. Since we're sorting into distinct categories, bee-wasp, we choose a classification algorithm.
Makes sense. On to step 4, the learning part.
Step 4, training. Yes, this is the core of it. The model learns from that 80% training data. Let's think about a simple neural network again, that black box. It has an input layer where features like hair amount go in, hidden layers in the middle doing calculations, and an output layer predicting bee or wasp. Neurons in these layers are connected by weights.
The strengths of the connection.
Exactly. During training, data flows forward through the network. That's called forward propagation. The network makes a prediction. It compares its prediction to the actual label, bee or wasp, in the training data. If it's wrong, it calculates the error and uses a process called backpropagation to adjust those weights and other parameters called biases slightly, trying to reduce the error next time.
So it corrects itself.
Continuously. It repeats this cycle, predict, check error, adjust thousands or millions of times. Each cycle is a training step, or epoch. It's literally learning by refining its internal connections based on feedback, like tuning an instrument until it hits the right note.
That's amazing. Okay, so after all that training, step 5.
Step 5, evaluation. Now you bring out that 20% testing data you saved, data the model has never seen before. You feed it through the trained model and see how accurately it predicts bee or wasp. This tells you how well it's likely to perform in the real world.
The moment of truth.
Pretty much. If the performance isn't good enough, you might need more data, different features, or... Step 6.
Step 6.
Step 6. Hyperparameter tuning. These are settings you control before training starts. Things like how fast the model learns, the learning rate, how many training steps to run, maybe the number of hidden layers or neurons in the network. Fine-tuning these can significantly boost performance. It's like adjusting the settings on your oven for a perfect bake.
So tweaking the overall learning strategy, not the data itself.
Exactly. And once you're happy with the evaluation and tuning, finally, step 7, prediction.
The payoff.
Right. You deploy your trained model. Now you can feed it a new unlabeled image of an insect, and it will confidently predict. That's a bee, or that's not a bee, it's a wasp.
Wow. That's such a clear breakdown from messy data to a working prediction machine. It really demystifies it, showing the methodical engineering behind it all.
It's definitely more engineering than magic, even if the results feel magical sometimes.
Okay, speaking of things that feel like magic,
Yeah.
let's talk about large language models, LLMs, like ChatGPT. How do they work? How do they generate text that sounds so human?
Right. LLMs are fascinating. And yeah, visualizations from experts like Andreas Horn really help here. It starts, again, with breaking things down. Your input text, your prompt, gets chopped into smaller pieces called tokens.
Tokens, like words or parts of words.
Exactly. Words, sometimes parts of words, punctuation. Each token then gets converted into a string of numbers, a vector, in what's called an embedding space. Think of it as a huge multidimensional map where words with similar meanings are located close together.
So happy and joyful would be near each other on this map.
Precisely. While happy and car would be far apart, the
Yeah.
computer understands relationships through these numerical distances.
Okay, that makes sense. What happens next?
Then comes something really clever. The attention mechanism, often self-attention. This is how the model figures out context. Which words in the sentence are most important to understanding other words?
Like knowing bank means riverbank, not money bank, based on the surrounding words.
Exactly. The attention mechanism weighs the relationships between all the tokens in the input, dynamically figuring out how much attention each token should pay to every other token. This refines their vector representations based on context.
So it's learning the connections within the sentence itself.
Right. After attention, these context-aware token vectors pass through multiple feed-forward layers. These are standard neural network layers that process each token individually, refining its meaning further, learning deeper semantic patterns. This layering is where the deep in deep learning really happens.
Layer upon layer of processing.
Exactly. And this whole cycle, attention, feed-forward layers, doesn't just happen once. It iterates. The tokens pass through these blocks maybe dozens, even hundreds of times, getting refined more and more with each pass.
Wow. Okay, so after all that iterating.
Finally, you get to prediction and sampling. The model uses the final, highly refined vector representation of the sequence so far to predict the next most likely token. It doesn't just pick the single most probable one, though. It generates a probability distribution over all possible next tokens.
Like a 50% chance the next word is the, 20% chance it's A. Exactly.
And then it samples from that distribution. It might pick the most likely one, or sometimes it picks a slightly less likely one to introduce some randomness and creativity. It adds that token to the sequence and then repeats the whole process to predict the next token and the next, generating the response one token at a time.
And that's how, if you ask it to describe an elephant.
It doesn't know what an elephant is. It starts generating based on the prompts tokens. Maybe it predicts A. Then based on A, it predicts mammal. Based on a mammal, it predicts with. Token by token, it's just building the most statistically plausible sequence based on the immense amount of text it was trained on.
That is such a key point. It's pattern matching and prediction on a massive scale, not understanding or consciousness.
Yeah.
That's a huge aha moment.
It really is. It's incredibly sophisticated mimicry based on statistics.
Okay, so we've gone deep into the mechanics. Let's zoom back out. Where is all this AI tech actually making an impact right now, transforming industries?
Oh, it's happening across the board. In business, AI is huge for automating tasks, analyzing data for insights you'd never find otherwise, helping with decisions.
Like what kind of things?
Think AI in marketing, personalizing ads and content for you. Or chatbots handling customer service basics 204/7. Or systems detecting fraudulent credit card transactions by spotting unusual patterns. It boosts efficiency, finds opportunities.
Why? Makes sense. What about healthcare?
Healthcare is seeing massive changes. AI is helping doctors diagnose diseases earlier and more accurately by analyzing medical images, X-rays, MRI, spotting things the human eye might miss. It's also speeding up drug discovery by analyzing vast data sets to find potential new treatments and enabling personalized medicine, tailoring treatments based on an individual's genetics and lifestyle.
That sounds incredibly promising.
It is. And in education, there's huge potential for personalized learning. AI tutors adapting to a student's pace, intelligent systems providing instant feedback, making education more tailored and effective.
Customizing the learning experience. I like that.
Yeah. And entertainment, of course.
Yeah.
We mentioned recommendation engines, Netflix, Spotify, that's AI learning your taste.
Definitely use those.
And in video games, AI controls non-player characters, making them behave more realistically, creating more immersive worlds. Plus, AI is now even generating music, art, writing, new creative tools.
It really is everywhere. Its versatility seems almost limitless, constantly finding new applications.
Absolutely. It's evolving so fast. And because of that, AI and machine learning are rapidly growing fields. The demand for people with these skills is skyrocketing. It's definitely a promising area if you're looking at careers.
Good point. Well, what an incredible journey we've taken today. We went from the basics, the types of AI, peered under the hood at ML and neural nets, walked through building a model step by step, figured out how LLMs chat without understanding, and saw its impact everywhere.
We covered a lot of ground.
We really did. And as we wrap up, I want to leave you, our listener, with a thought to chew on, something that came up in the research. Given how much AI learns from us, from our data, our behavior, the text and images we create, what responsibility do we humans have in shaping the experiences it learns from? How do we guide it towards a future that's, beneficial for everyone?
That's a deep question. Really important to consider.
It is. Well, thank you so much for joining us on this deep dive into artificial intelligence. We really hope you had some of those aha moments and maybe the magic feels a bit more understandable now.
Hopefully less magic, more amazing engineering.
Exactly. Please, if you enjoy this, take a second to like it, leave a comment, share your biggest takeaway or any questions that popped up. We genuinely love hearing from you.
And if you want to keep learning, definitely check out resources from, say, university computer science departments. Many have great introductory materials. Or look for beginner guides on AI and ML from reputable tech news sites. There's always more to explore.
Great suggestions. All right, until next time, keep exploring, keep learning, and we'll see you back here for another deep dive into new knowledge.